Alright, let's talk about regularization. If you're just getting started with machine learning, you might have heard this word tossed around a lot. But what does it actually mean, and why should you care? Imagine teaching a dog to fetch. If you give it 10 toys, but only one is the real target, and you reward it time it picks up a toy, any toy, the dog's going to be confused. It'll just learn random stuff. That's kind of what happens when a model overfits. It learns not just the important patterns, but all the noise and distractions in your data, making it perform badly on new data. Regularization is like giving the dog clearer instructions and maybe toys to choose from. It's a way to guide your model so it focuses on what matters, not just memorizing every weird detail. Let's break down the two most common types, ridge and lasso. First up, ridge regression, also called L2 regularization. Here's the trick. When training your model, you add a little penalty for using really large weights or coefficients. The bigger the coefficient, the bigger the penalty. It's like saying, hey, don't get too excited about any one feature. Keep things balanced. The more you crank up the penalty using a parameter called alpha, the more the model shrinks those weights. But here's the catch, with ridge, none of those coefficients are ever forced to exactly 0. The model still uses all your features but just dials down their influence so it doesn't get carried away. Ridge is super handy when you've got lots of features, and you think many of them have at least effect. Now, lasso regression. This is L1 regularization. Lasso likes to play hardball. Instead of penalizing the squares of the coefficients, it penalizes their absolute values. What does that mean for you? Lasso can actually push some coefficients all the way down to 0. It's like cleaning out your closet. If you haven't used a feature in a while, Lasso will toss it out. This makes Lasso perfect when you suspect only a handful of features really matter, and you want your model to ignore the rest automatically. But what if you want the best of both worlds? That's where Elastic Net comes in. It mixes ridge and lasso, giving you a blend of both penalties. With Elastic Net, you get the stability of ridge, which is great when your features are similar and kind of overlap. You get the feature selection of lasso. You control how much of each flavor you want using 2 parameters, one for the overall penalty, and one for how much you want to mix L1 and L2. So to wrap it up, regularization is your secret weapon against overfitting. Ridge keeps everything in play but dials it down. Lasso gets rid of the clutter. Elastic Net finds the middle ground. Play around with these, and you'll make your models not just smarter, but more reliable. Thanks for watching. Happy modeling!